Okay. Guys, the last problem here, 15x squared. We have 3 over 2x squared plus 2x plus 5, oops, that's a plus 5 divided by x squared minus 3x minus 4. Okay? Before we get started, ladies and gents, I want to recognize that the denominators are both quadratic expressions. Okay? And if you see a quadratic expression, what's one thing we can do to identify its factors? Hint, hint. Identify the numbers that multiply. You could use a box thing, right? We could use factoring, a factoring method, right? Like the tabular method, or yeah, let's do that. Why not? Let's use the tabular method. So well, let's look at this first expression here. What is the greatest common factor of 2x squared and 2x? They both have an x. What else do they share? A 2. So let's pull that out. Okay, let's factor out the 2x. Now, what times 2x gives us 2x squared? Right. What times 2x gives us 2x? 1. Okay, so what we've just done is factored the greatest common factor out of these two terms here, and the greatest common factor was 2x. Okay, we haven't changed the numerator; that stays the same. I think that was an airplane. Guys, with this one, let's use a tabular method. I really like that method. I think it's just awesome, but some of y'all would disagree with me. I don't care. I like it. The first number goes in the first box, right? X squared. The last term goes in the last box, negative 4. And the sum of these two boxes have to add or subtract to equal negative 3x. All right? We have to think about what are the factors of 4x squared that add to equal 3x. Anybody? Factors of 4 that add to 3 or subtract to equal negative 3? 4 and 1. Good. Which one's negative? Negative 4. So this will be negative 4x, and this will be positive 1x. If we take out the greatest common factor, it's going to be an x here. It'll be a 1 here, an x up here, and a negative 4. Good. Note how all of these are all negative, right? So negative 4 here. So the common denominator, or the denominator in this case, not the common denominator, but the denominator is going to be x minus 4 and x plus 1. Okay. Minus 4, x plus 1. And remember, the numerator hasn't changed. The top has not changed. We've just factored the denominator. So this still remains as 5. Okay? Now, guys, we're going to do the fun part. Okay? We have to identify what are the common factors that do not need to be multiplied, and what are the factors that are missing. Okay? So if we're looking at this fraction, and we're looking at the denominator, what factor in the denominator is it missing when compared to this fraction? It has an x plus 1. What is it missing here? It's missing an x minus 4. So what we're going to do is we're going to multiply this fraction by this factor here, x minus 4, because it's missing it, all right? Let's go ahead and write that there. What's going to have a 2x? So let's multiply this thing over here by x minus 4 over x minus 4. Okay? So we're adding this factor x minus 4. Let's look at this fraction, okay? Jared, let's look at this fraction over here. If we're looking at the denominator, what is the factor that it's missing when compared to this fraction? It's missing that 2x there. Y'all agree? Yeah. It has the x minus 4. It has the x plus 1, but it's missing that 2x. So we got to multiply that fraction by 2x. Multiply by 2x. Okay? 2x on 2x. Okay? Let's rewrite the fraction with a common denominator. The common denominator is going to be 2x, x plus 1, x minus 4. Okay, let's write the common denominator. What do we get? We get 2x times x plus 1 times x minus 4. Gentlemen? Ladies? Oh, it sounds really pretty though. Wow, it sounds really nice. Guys, these are the factors that make up these denominators, okay? Now we got to simplify the numerators, okay? So let's multiply it out. Mark, what is 3 times x? Very good. So 3 times x is 3x. Mark, what's 3 times negative 4? Negative 12, good. Gabby, what's 5 times 2x? Awesome. Plus 10x. Let's simplify. We have two common terms here, like terms. 10x's plus 3x's is how many x's? 13x, great. We're going to rewrite this constant here, this term, this integer, negative 12, all over this behemoth down here, okay? I know, guys, this is the last one I'm going to write. 2x times x plus 1 times x minus 4. Yeah, guys, these problems, hopefully not tomorrow, but wait, tomorrow's Wednesday. On Thursday, I'll show you how these pop up in real life, okay? One of the common examples is, on Thursday, I'll show you the real world application of rational equations. Because tomorrow we're going to solve equations that include adding and subtracting rational equations. We can do, well, if you kind of work on them, but we kind of like guide you through. Yeah, we're fine. The real world application. Ladies and gentlemen, what I want you to do is to work through these exercises 5 through 8 on the following page. And then I'd like you to work through problem 2. Okay, problem 2, numbers, letters A, D, G, J, M. Okay? Or you know what? Better yet, y'all can pick any 5 problems you'd like to work through problem 2. Okay? So it's up to you. Work through problems, like I said, 5 through 8. I'm gonna stop this.